All right. So today we're going to be doing two things. So for our first project, we're going to just be making a normal like ChatGPT enabled 8-ball. That's like a very simple, quick practice idea. And then next up, we're going to choose an idea from the brainstorming we did yesterday, and we're going to see if we can build that. So I'm going to start sharing my screen. First thing you need whenever you're making one of these apps, essentially, is an outline. So make sure whenever you're building something to make one of these, because you always need to make sure you know the parameters of what your app should do, and then you can figure out all the little kinks and details of how you're going to do it later. So first up for the outline, let's say app is going to be a ChatGPT enabled 8-ball and have a features list. First thing we need is user inputs. Next up, we need connection to ChatGPT. Next up, we need response back with the display. So now that we have a basic feature outline, what we can do is just draft up a quick design of what we want. So before we move into anything complex like Figma, first thing we can easily do is just draw it out. Okay. So I have here is a whiteboard. Please turn on my camera. All right. So very important thing to have either a piece of paper or a whiteboard when we do these sort of things. Whiteboard is way more useful though, because you can easily erase and then quickly change features if you don't like the look of things. So first of all, we got to decide what platform we want to make this for, because we're App in Club. We're going to be designing an MIT App Inventor app. So when choosing a platform, usually first you want to think about who's going to access it and how. So for this app, let's say we want people to access it from their phones. So from their phones, there's a bunch of different frameworks that we can use. App Inventor is one, but of course, if you want to go more focused into coding, you can go into React Native or other frameworks like Dart, Kotlin, that sort of stuff. But we're going to stick with MIT App Inventor. So then, because we're using a phone app, we have different screens. So then let's say we want this to be portrait mode. We can draw like a little screen like this. Then for features, let's say we want just an 8-ball image, title. It's like this. So we have an icon as well as the title. Now let's say we need a user input. So we'll have a little text box here. Now we have a text box and submit button. Now last up, we need to display the ChatGPT's response. So then let's have another block. And we have this piece just having the response that we want. So now that we have this outline, for app, it's really simple. So we just need one screen. So then what we can do is we can go on Figma. So Figma is essentially something that people can use to do more complex designs for their app. So this is usually for more complicated apps that have like multiple screens, navigation between screens. There's more complicated detail. But it's also useful for just general app design because then you can see exactly how you want it. And then once you have it out in Figma, then essentially you can code it up to make sure it looks exactly as you wanted it to, just like how you made it in Figma. So because we're using a phone app through Figma, we can go into plugins. Then you can actually find a plugin. So you can search things up here. And because we want a phone screen, we can just search it by phone. And the first one that pops up is a little bit mockup. So this works pretty well for us. Add a dark frame. And now essentially we just easily have a phone screen. Now with this phone screen, just actually start adding in our components. So here we have the text box. Like this. Well, then change the font to how we like it. bold, middle. Then we can have an image. So if we just search up 8-ball, then something like this works. So copy this image and paste it in here. That's it correctly. And put this here. We need the user input box. So then go into here, we make a rectangle. And now we have this rectangle. We can have another one just for the button. Now we can stylize these however we want. So like let's say we want the user input to have white background. Have a bit of a border. So Figma actually calls it stroke. This little bit of thickness, let's say. Then I'm pretty sure there's a place where you can round it out. Yep, right here. So for here, you can say like 50 pixels. Oh, let's say 10. Now pick round. Do the same thing for the button. Except let's say this time we want to make it green. And here we add some text. Unbold it, decrease the font size. Copy and paste this. Add some more text. Expand it out. Put it on the side. Change the color. Do something a bit darker. Still light because okay, 20. Okay. So when you're essentially having inputs, just quickly change this to like type here. Okay, so when you're assigning inputs and then you want to decide what the user is supposed to type in there, you have to tell them what they're supposed to put in. So you can either do that through a label, where essentially you have this above the input, or a placeholder, where essentially you have it inside the input. So then placeholders usually look a bit more neat, except labels are a little bit better for accessibility because people won't accidentally think that they already have something typed inside. So then we can leave it as here though, because that's fairly easy to do. And let's say we're making this for a hackathon, so we want to make sure everything goes relatively quickly. Now we have this, have one final text box. Right here. Now we're not actually going to have results here on the actual screen, but this just gives us a little idea of how much space we need for a placeholder. So now this general app design looks pretty good. So we can move on to MIT App Inventor and then start building it up. So I already created a new project. Let's say, yeah, font size works. So then from here, you actually have some basic info about the screen on here. So let's say we want to keep it as a responsive sizing. We don't want to display the title. or the status bar, so it looks a bit more neat. Need to make sure it's scrollable. Usually when you're making responsive apps, you should have it be scrollable, especially because we have a lot of text right here that can pop up. And when you have scrollable, essentially things don't get stretched weirdly when you're on different device sizes. All right, so now we have it like this. First of all, we can start inputting the stuff that we need. So we have a title up here. This here. ChatGPT 8-ball. So we can copy inside the text, paste that inside the label. And we want to format it to look like this. So text size is fine. We can make it bolded. Increase the text size. So here we have it as like 40. So we set this to 40. We want this to be center aligned. Because not exactly center aligned, we need to fill with parent. So now we have this part done. Next up, we want the image of the 8-ball. So we add an image component. And then, okay, so because we have to upload the file, we can download this 8-ball image we have. Import it here. You can see this is a little big. So if we want to scale the image to fit, have the width, fill the parent. Height should be automatic. So now that we have at least this much done, we can go quickly check out the design on our phones. So if we open up the App Inventor app, we can connect it with the QR code of the AI companion. Now it's connecting up. Now, as you can see, we have it like this. So this is looking kind of good, except as you can see, there's a little gap at the top because of the way this phone is formatted. So what you can fix this is we can add a little padding at the top. So height, let's say we can have this 10%. Still not enough, so let's say 20%. All right, looks pretty good. So now we have it like this. It's above the top, except now there's a little bit too much spacing between there and there. So we can see the boundary boxes by giving this thing a background color. You can do this in like any language. This just makes it easier to see boundary color. So because now we do it like this, we see this is placed in the middle. This is actually a bad approach for us because there's too much empty space at the bottom. So what we can do instead is have a little piece of padding at the top, like another label. Usually you can just do this with styling in other languages, except MIT App Inventor, you just have to add a new component and then size this a little bit. So let's say have our height of this component be 10%. Actually 5% works. We can remove the fixed height of this, set that back to automatic. And now we can see the boundary box is as it should be. So now we can set the background color back to normal. Our 8-ball is also a little bit too big though. So we can set this to like around 80% width. And then because this is looking a little off center, we can go into our layouts, horizontal alignment, put this inside of here, make our horizontal alignment full width, and then center whatever's inside. Then let's say give this a quick background color. So now it looks like this. So we can actually make the 8-ball a little bit smaller. we can do the same with the height. Actually, we can leave the height alone for now. Okay, so now that we have this much done, fix the background color again. We can add in an input. It's the way we do this in MIT Adventure. Well, before we add in the input, we can see we have this next to this. Because Adventure has things stacked, we can have another horizontal alignment so that we can place these things next to each other. Scroll down a bit so we can get to the bottom. There we go. Make this full width again. And inside of here, we can place button for submit button and a text box for user input. There we go. Let's have our text box take as much space as possible. Change the button text to submit. Have our background color be green. White font color. So look here, our submit button is a little bit too green, too bright. So we can fine tune it by clicking custom, then decreasing brightness like with the slider. Now it looks much better. Change the shape of this with here, make it rounded. And we can make this, okay. So as you can see, this doesn't exactly line up for our phone screen. So that's why it's best to have this open at the same time so we can see this in real time where it's actually happening. So instead, we can see that give this text box a background color, let's say cyan. This text box is not filling up the space it's supposed to. So I can do a little experimenting. You can see when we make the text box fill parent width, it actually makes the button do that for some reason. So we can fix this by just setting our width to just a certain percent, like 8%. And having our horizontal arrangement center everything. So now this looks much better. And then we can change how we want this to look. So we want to increase the size of the text box bit, let's say. It's a little bit off right now. So we can take this, add a little extra height. Let's see if fill parent works. Yep, fill parent works pretty well. And because our text box is cyan right now, we can fix it back to what it should be. So no background color, but so because App Inventor doesn't really support borders, I guess we can just have a background color of, let's say, low gray so we can see it better. It's a bit too dark, so let's increase the brightness a bit. Or we can actually just go for a fully black text box and then have white text with a hint. So instead of placeholder, App Inventor calls the inside text like this a hint. You can see it very closely here, except because it doesn't look so good, we can have a label instead. So go into here, get rid of the hint, and then add a label on top. That says, just check this row. Okay. So we can have this say, type here. Space at the start to give it some extra margins. All right, so it looks pretty good on the phone. So our text box text to be white so that the user can see what they're typing. Well, it's looking pretty good, except when we type, it does this weird squishing thing. So in order to fix this, we need to figure out what's wrong. So go back to the screen. See if Scrollable is causing it. No. See if fixed sizing fixes it. No. Didn't change anything. Let's see. What's too big? Just make sure users import it very quickly. And then might be the image. So if we delete the image, we can see what happens. Essentially, just make it invisible for now. It's acting a bit strangely. So let's quickly see if we can just reset, see if that fixes it. So it still seems to be squishing a bit. So let's make this image visible once again. Let's quickly add in a label to make sure we're actually scrollable. We can have this just have a lot of text. As you can see here, oh, it's not fully actually scrollable. So this might be a bug with the iPhone. Check on the screen to make sure scrollable is actually doing what it should be. And it seems like it's not. So because it's a bug with the iPhone, I think what happens is we just have to use an Android when we're testing later. Except for now, I think it should be fine because we're not too focused on styling for now. So we can have a label here. And then if we're going to interact with these on the backend part, we want to give these things labels like this. So let's call this response. Submit button. And what? Okay. So now that we at least have some of our general UI, which is user interface done, we can figure out how to get the backend done. So from our outline, we see that we want a connection to ChatGPT. We want it to respond with our data. So now let's assume we don't know anything about how we want to get information to and from ChatGPT. Now we can do some research on what we want to do. So the first thing you want to do whenever you want to interact with something we check if it has an API. Search up ChatGPT API. You can see this right here. So like OpenAI does have an API. We scroll through here, see if we'll find it. Get started. Going to log in with my email account. Okay. Suddenly see this is what we call documentation, because essentially it has all the info on how you want to build your apps and how to interact with the API. So through here, we see there's a Python API. We're not using Python, we're using MIT App Inventor. So what we want is something called a REST API, which essentially controls requests to and from the API using requests, which are essentially just URLs and then types like get, post, delete, that sort of thing. We interact with that through a web component, which we can find inside of Connectivity, I think. Yep. We can leave this here for now. So now if we go into here, just search through some of the documentation. This is in the beta, so we need to see this. This is all Python. C libraries. There's Python bindings, Node.js, C#, C++. All this stuff we're not going to be using because we're using REST. See if we can find it here. So what we can do instead is just search on the internet. So search up ChatGPT API, REST API. I want to see if they have documentation. Just opens up some tabs real quick. Okay, here we go. So this is the thing that we want because it has completions, and see how it says CURL? This is essentially the type that we want. So I'm going to be teaching guys also how to read this and understand how it all works. Let me see if there's any better documentations. Not really. So we're going to have to be using this. So based on this, we need to just read through a bit of this. Authentication. So we can see we need an API key. So an API key essentially authorizes you with the server so that it knows that you're the one making the request. So if it ever needs to bill anything or pay you, or you pay it for its services, then that's how it knows. That's why you always want to make sure you keep your API key secret. Go through here. We see curl. This is how you do that stuff. We scroll through. This is how you make requests. Just quickly skim through all this. So looking through this, completions doesn't seem what we want, but chat does. So if we read through this, see that if we post this URL, then it'll give us the thing that we want. So then what we're going to do, we're going to start building this on the MIT App Inventor side. Now this be the Web 1 component. You can copy this URL into here. Okay. So then from here, we can go into the submit button. When we click it, we need to send this says a post request. So we're going to post text. Oh. Then for our text, we're going to decide that later. And then what we want to do is when we get a response from it, we're going to do stuff. So let's just leave this on the side for now. Let's see the format of what we need. So if we look into here, you can see -h, this means a header. So whenever you make requests using REST or curl or whatever, you need to put in something called headers. So headers are essentially just little extra pieces of data that you send to the server, and then it gives it some extra information that it needs. So this header is telling it that we want to return the, sorry, no, this is telling us that we're passing in information as JSON, which is just a form of data transfer. And then this one is telling us that we want our authorization to be this bearer. So this just is the authorization that we need. So from here, we can quickly implement the headers by assigning them when we initialize the app. So for screen 1, whenever we initialize it, we need to set some headers. So we do that through here. And let's say we don't know how to do headers in MIT App Inventor. Let's just quickly close out some tabs. Set aside for now. Here. All right. So because we don't know how to do this, we just quickly Google it. MIT App Inventor, web headers. So here we have some documentation. This one's not that good. So go to here, search for MIT App Inventor web component. We have something right here. So this essentially is documentation for all of the MIT App Inventor, the components in this connectivity section. We want to understand the web component. So we click right here in the table of contents. So then we want to figure out where the headers are. So here we can see we don't need methods. So right now we just want to focus on the request headers. So it's a list, which is blocks only, which sets the request headers. So now we want to figure out how that works. So we know it's a list. So it's like this. Goes like this. It doesn't exactly say what the format should be. So because of this, we need to just figure out some examples. So in Google that. Check this out here. So here we see what we want to do, web request.request header, set that. So now from here we can see it's a 2D list, which essentially means you have lists inside the list. And so we can see that each of these little key value pairs, which we can see here, content type, that's the key, application JSON is the value. Each of these is stored inside a list of length 2, and each of these is in a bigger list which has all the headers in it. So because we need 2 headers right here, we're going to have 2 lists of length 2, like this. For our first element, it should be the key. So add text block. We paste these in here, content type, authorization. This one, we're just going to set to application/JSON. And for authorization, we want it to be bear space and then our OpenAI API key. So then for this, we want to join two pieces of text. There's one being bare, the second one being our API key. So then first thing we need to do is figure out where our get an API key. So we can do this through here. So then we can create a new key. Let's call this one for 8-ball. Copy the key here. And then I'm going to delete this API key after this meeting because you never want to have open and exposed API keys because people can use them pretty much infinitely or until your credit card runs out of money if you connect this up to things. And because OpenAI, you have to connect it up to a debit card or a credit card or something, you never want to make sure this thing gets leaked. So let's first of all store this API key inside of a global variable. Let's say API key. Some text in here. Paste that in and put that there. There you go. So now that our headers are set, now we need to deal with the data. So with this, we can see that we did web1.post text. So this, what the text that gets posted is essentially whatever's in here. So this is something called JSON, which is where you can format your data. So you can see there's one big object, and inside of this object, there are keys, and each key has a value. So this matches up essentially with a dictionary in MIT App Inventor, which is in this panel, where you have keys and values. And the way you convert dictionaries into JSON and JSON back into dictionaries is in this web1 component, where we scroll down, we can have JSON object encode. Turns the value of built-in type in JSON notation. So here, send here. And for our JSON object, put this into here. The dictionary should have, first key is the model. Let's follow the tutorial for now. So text model, and the value should be GPT 3.5 Turbo. All right, so now that we have that, now we need to have messages. So these essentially mean dictionary. So then you see these symbols, you're like, what does this mean? So what this is it's a square bracket. Essentially, it represents an array. And an array is essentially just a list. We have that in MIT App Inventor too. So you need to make a new list. Okay, now we see it has role and content. So now in ChatGPT, essentially, you have a bunch of different messages. The user can send messages, and the AI can send back messages. So then whoever sends it is represented with the key of role, and then the content of each message is represented with this content key. So for this, we need to make a new dictionary. For our key, we'll have role user, so role user. Then in here we have content, and then in this case it says hello. But instead, we want to put in our user input. So we can here, and then have the inputs text. So now that we have this set up, this should be all that we need. So now in order to see if we get back a response, it should be passed back into web1.getText. So then what we want to do, if we look into this API reference, see the response looks like this. This looks extremely ugly, but if we look into here, we can see exactly what we need. that is inside this object, the choices key, the message key. Sorry, choices, we see there's an array. So you want the first in the elements. And then we want that message. So in order to convert, first of all, we want to set the text of the response to this. So we'll set response of text. In order to convert this text response, this is actually just one big piece of text. In order to convert that into a dictionary, we can use this web1 component again. Go into JSON text decode with dictionaries. The response content should be inside of here. So if we go into here, we can see we want the choice element. So we want the dictionary, get value for key in dictionary. This is the going to be dictionary. And the key is choices. And inside of choices, there's an array. So we want the first elements of this. So we want to select list item. This list, we want the index of, let's see. I forgot whether or not MIT Adventure starts index of 1. So let me just Google that. Index. So right here it says first list items at index 1. So let's set this to index 1. Now we have the first one here. We want that message. So again, we copy this and get rid of this. Inside here, we want the content. This. Some blocks. So as you can see, this is all what we call nested because you have objects inside of objects and arrays inside of objects and that sort of stuff. So then that's why we have a bunch of different layers. So if we go through each of them, we can see first go look for choices inside of this object. And then get the first index. So that's this object. We want the message, which is this. We want the content, which is this. And so now that we have all of that, let's test it. So right now I have it hooked up to the phone. Let's try to put in some text, like let's say hello. Then let's click submit. Car pair required irritants identifier call yellow primitive. Okay, so this, we don't know what the heck this means. So the way we debug these errors is just changing things. So let's say we want to just quickly change the label text of something. So the first thing we want to do is search for where the error is. So we know it's not initialization. So let's click check if it's the submit button. Let's go in, submit again. So because the text was changed, we know that the error was after this. So then let's see if it was this post text that was broken. So go into here, click submit again. Once again, dismiss. So now because this text did not get changed, we know that this is where the error was. So if we look in here, make a dictionary, well, user, content that. All this in general makes sense. So let's check out what JSON object encode really does. So if we go back into App Inventor documentation for a component, JSON object and code. Okay. So in order to make sure this is what we want, we can put this into here, run this again, and let's see if it displays everything correctly. Because it displays this all here, we know something is up with the actual posting of text. Okay. So let's delete this. Actually, let me just quickly try refreshing the companion screen, see if that does anything. So if we go into here, we can see that by refreshing the companion screen, it actually started to work. So that means essentially our error previously was just something in our screen initialization. And because I didn't reinitialize the screen, it did not work. So now that the screen's reinitialized, it does work in fact. Now let's say if we ask the app hello, click submit. There's hello, how can I assist you today? So now that this much works, we can actually make it into an 8-ball. So in order to do this, we can prompt it with something specific. So if we go into here, ChatGPT has something called, let's see, we go into these roles. All right, so there's system, user, assistant. So system is the AI, user is the user input, but system is actually allows you to assign roles to the GPT. So we can expand this to 2 items very quickly. I'm going to ChatGPT a system message. With this, we can essentially tell GPT what it is. So we can just give it a quick description of what it should be. So you are an 8-ball or a magic 8-ball. That gives quick and concise. Yes or no answers, questions you are asked, little bits of elaboration. And now we can test this. Let's see. Is the sky blue today? You see ChatGPT responds, yes, the sky is blue today. So now, because whenever we click the submit button, however, you can see there's a bit of time before it comes up with a response. So what we can do is give a little bit of a loading screen. So because it takes time from when it sends the request and the request comes back, we can just set the response text to, let's say, loading ... as like a little placeholder. So right here. Just adds a little bit of extra content. We can have it reset the input whenever you click submit so that the user doesn't have to eliminate it the next time they want to ask a question. That'll be right here. So now if we refresh our companion screen, we type in, is the sky blue today? I'm going to increase this size just so the response size, so it's a little bit easier to see on your side. Make this 30 for now. Okay, so if I type, is the sky blue today? I click the submit button. See, it starts off with loading. It gives me the answer. I can set this back to the original size, 14. And as you can see, our text box did go back to normal. So this app is essentially finished now. So if we go back to the designer, you can see everything looks good. So then in order to submit it to Computation Seriously, you can either build it into an APK app, so like this. This takes a while, but once you build into an APK, essentially it becomes a fully fledged app, which you can open on Android devices and becomes fully functional. No like weird companion stuff. And this is actually a good final test for whenever you build an app. So every time you finish up, you can build it into an APK, scan it on an Android device, download it, and then see if it works. Work from there, and it's all good. So you can download it like this. And then usually whenever you're in hackathons or whatever, you can upload the APK. So do any of you guys have questions? All right, since we don't have enough time to make another app, I'll just do a quick review of what happened during this thing, and then we can conclude the meeting. So the first thing we want to do whenever we make an app is create an outline of essentially what we want it to do. Once we have the outline, we can draw a little example of what we want on a whiteboard or a piece of paper. We can go from that whiteboard to an actual functional app design by going into an app like Figma and then creating our UI here. We can add in extra things like phone screens with plugins, like a little bit mockup. Once we have it all functional in Figma, we can go onto MIT App Inventor, design our designer, and then we code the actual backend behind this and the logic using these blocks. And then once we do that, in order to do that, actually, we can, if we don't know anything specific that we need to know to build the app, we can go onto Google things. Documentation is one thing that you really need. And documentation essentially the developers of the API explaining how it works. You hook up APIs using REST, which uses post requests, get requests, that sort of thing, headers and data. You send data through into the API using JSON, which you can use with dictionaries and JSON object encode and decode. And then from the API, you can see how to format all of that stuff. And then you know what to do with the request and use the web component to hook it up fully. And when you fully finish with your app, you've tested it all, you can build it into an APK, and that turns into a fully fledged app, which you can send to judges or hackathons and then use. So that's pretty much concludes today's overall workshop on how to go from an idea in your head into a fully fledged app. So thank you guys for coming, and hopefully you guys can come to the final concluding thoughts of the general workshop. Bye guys.